then I have like the backed out USB.
Did you find a new laptop? Yeah. Oh, okay. But it takes a while. I have to download the slides.
Hello, can you hear me? Someone in the back, like Kireti, can you hear me? Okay, so if anyone wondering what we're doing, we're trying to find adapters for the projector. We couldn't do that, so Nick ran down to the shop and bought a new computer. And he's trying to set it up. It will take a few minutes. HTM1. Ah, here we go. So please take your seat, sit down, focus the front of the room. We are about to start in a minute. You're not hearing me. Is this one better?
That one's better.
That one, okay. We use this one. But we need that one for the chairs. So this is the MPLS working group meeting in Singapore. We started out with a pretty light agenda, but it's actually been growing over time. So we will try to keep people to the allocated times. I just want to check one thing. Su Feng, are you going to do the Young update? Okay, fine. Then everything is set, and we have all the slides. You hear? We have all the slides. That's actually one of the first times ever. And normally people come running up the slides on USB sticks and things like that. And I'm just rambling, because giving Nick time to get.
What are you doing here?
I think this is okay now. Yes, yes.
Then I can sit down. So, time to start. You have the note well. This is actually the third version of the note well I've seen this week. They are the same. They are a little bit different graphically. It basically says that anything you do, say, and publish and kind of write down on a whiteboard or whatever in an IETF meeting is a contribution, and you are required to follow the IPR and copyright rules that are taken down in the RFCs.
Can you speak to the mic?
I can speak to the room if you want. So let's go ahead. We have the administrative information here. I know, Rakesh, you will take notes on Etherpad. Anyone that actually want to help him can do that. And also anyone that want to take notes during a meeting can actually send them to Tarek after the meeting. It's very helpful to get extra notes coming in from different sources. You know where to find the meeting material in the data tracker. There's a Meet Echo. There are a few people on. I don't see who it is. Oh, Eric Gray is there. Okay, welcome, Eric. And then, yeah, you have the agenda and the slides at the meeting materials. Please move ahead. So this is the agenda. It has filled out a little bit over the last day or two, but we're still well within, I think we have like 5 minutes left at the end. But let's see. Stuart, you are not on the, you are number 11, talking about the report on what actually was discussed on in the PALS working group yesterday. We have slides, but we don't have it on the agenda. So there is 11th bullet on that agenda. Okay, move on. Blue sheets has been started. Keep them circulating and bring them back to the chairs. We have 4 erratas. They are currently in a state where it looks like they are not approved. But basically, I will send a mail to Deborah later today and say approve all 4 of them and hold them for potential updates to the documents. There is a little bit wrinkle on that, but I will cover that in the mail. That the last 2 erratas point to IPv4 and IPv6, and the erratas is written point only to IPv4. So we need to recapture that and we approve the data, approve the errata. Okay. So we have an issue that we discussed in PALS working group yesterday, and that's on MD5. When we kind of designed an LDP like 20 years ago, MD5 was not state-of-the-art. It was just something we used. And it's have over time practically become deprecated. We have taken an initiative between PALS and MPLS working group chairs to actually start writing a draft that actually tells people what is needed to implement instead of or together with MD5 in the future, and that we actually can move over to eventually. Liaisons. We have no outgoing liaison, but we should have one. We should actually tell ITUT that the MPLS TP shared ring protection has been published. And I think we approved it a couple of times, but it hasn't gone out, and I don't know why. Okay. Did we jump the incoming? Okay. Okay. We also had 2 incoming liaisons from ITUT and BBF, yes. It's rather as to us and other working groups, so we need to coordinate on that. We have 5 new RFCs since last time, and that's a little bit funny because we had people making a routing area presentation on Sunday, and I looked at the old slides and I said, we are doing like 3 or 4 RFCs between each meeting. And I said, well, no, we're not up to that speed anymore. We're going slower. And now we did 5 instead of 3 or 4. So we keep in pace. Next one. We have 3 documents in the ISG review. Deborah had comments on one of them, and I think you will actually send a mail to the author on that, explaining what the issue is. Or do you expect me to do it? I do it. Will you send the mail to the author? Yeah, okay, thanks. And then we have 3 new working group drafts since last time. Okay. So a couple of documents has been updated, especially the young models for LDP and MLDP, and the spring entropy label that actually will be discussed later on the agenda. We have a number of working group documents that is going to show up. Some of them will show up in a status report. They actually have 2 different status reports. We're doing Yang separately towards the end of the meeting, and we're doing the other documents in this working group share status report. Okay. This is the. I think the header is wrong. It should be non-working group document, because this is all individual document. Yeah. And those are things we're looking to actually starting the working group adoption poll for in a not too far future. Okay. Yeah, this is continuing the list. So here is a short progress update. The RMR draft, what the authors say is they are fairly happy with the document as it is. There are a few outstanding issues, and they are requesting comments. And I've been kicking a couple of the authors actually to go and actually find people that actually do the reviews. And then we have the MPLS summary FRR, RSVPTE. So it was kind of recently adopted, haven't changed that much since then. Please review if you have the time. And then the static Yang and base Yang models, they are work in progress, and they are progressing. There have been lots of changes around, not particularly to the draft, but in the environment for the draft. So I think you have a stable environment now. Okay. We ask for status report for each meeting, and this time we have 6 missing, which is actually a little bit better than it used to be. Maybe because we have a fewer drafts at the moment, but we are getting better and better response on that request. If you feel that you are an author and have not responded to that request for information, don't feel too bothered. It's not a big problem. Anything is under control, so we know that. Okay. So the student says that not every author has actually got the request. You should have it, but I talked to Tarek about it. Okay, next. Okay, so we're ready to jump into the agenda. Who is first? Stefan? I think. Entropy label. Do you have a clicker? Yeah. We had one before. Ah, there it is. Yeah. What does it say? It's interesting with a new laptop. What happened? Yeah, it works.
Thank you.
Perfect.
Hi, everyone. So I'm Stefan Nikowski. I will present you the update on the entropy label draft for spring.
question.
Sure.
I think you sent me a mail, and you're actually presenting as a final presentation before going to working group last call. Is that?
Again, yes.
That's the agreement you and I had, I think.
Yeah.
Okay.
So just a couple of history and a reminder of the purpose of the draft. So we want to give the ability to provide entropy to achieve a good load balancing when we are putting some traffic on top of an SR or SRT tunnel. And the main challenge here is when we are using an SRT tunnel, we are stacking possibly a lot of labels. So where do we insert the entropy label within this stack? So if we are looking at the existing entropy label RFC, we are putting the entropy label just behind the tunnel label. But here we don't have one tunnel label, we have many tunnel labels. So if we put it just behind the last label, there may be some issue for the routers to look at it because it may be too deep. So yes, there is a challenge that we need to overcome. So this is an old draft, not too old, but quite old now. So we started in 2014. And we came with multiple solutions and one recommendation, which is to insert one or multiple entropy labels within this stack, which corresponds to a particular SRT tunnel. And we need to insert those labels and at a readable depth to make the routers on the path able to read this entropy label and use it for load balancing purpose. So there was a first working group last call on this document. It was, I think, on May 2016, but this working group last call failed. And the main concerns and disagreements on the draft at this time was first on the definition on what we called the RLD, so the readable label depth, and also the entropy label capability that we associated with it. And also how was and also the proposal on how to insert those entropy labels in the stack. It was seen as maybe too strict, while other considerations may need to be taken into account. So in Chicago, we had a meeting with a lot of people to try to solve this issue. And we came with a new proposal, which was introduced in version 5 of the draft, and then we updated based on the commentary we received. So what are the big changes? First of all, the main solution does not change. So we are still keeping this idea of inserting one or multiple ELI-EL pairs within the stack at a readable label depth. So what we are improving in this latest version of the draft is we are improving the definition of the RLD, so this readable label depth, which change now to what we call an entropy readable label depth. Why this change? Because in the discussion, we found that there may be multiple use cases for the RLD, maybe something else that the entropy label. So a router may be able to look at 5 labels, but it may not be able to hash on the entropy label inside. So there is a difference between reading the labels and being able to do a particular action on the labels that it can read. So we came with this new definition of entropy readable label depth, which is dedicated to entropy label. This means that if someone has another use case that involves the ability of a router to read the label stack, there may be other readable label depth defined. So the ERLD definition is the ability for a router to read an MPLS within an MPLS packet on its incoming interface. So it's the number of labels on the incoming interface, starting from the top of a stack. And the other point is that it must be able to use these labels in its load balancing function, which is an important point for the entropy label. So this means that as a consequence, if the entropy label is within this ERLD, we are sure that it will be used in the load balancing function of the router.
Stefan?
Yeah.
Kiriti Kompella. I think it's important to say, because we're making this change, to say you don't have to actually read the labels in between.
I don't hear you very well. You're a bit far from the mic.
I'll just pick up the whole thing. Okay.
Thank you.
I think it's important to say that you can read the entropy label. The rest of the labels are not so important because the entropy is captured there. If you can read all of them, great. But if you can read to that point, for example, if you think that you have microcode that skips everything, looks for ELI, and then says, I want the next label, you're good.
You're right.
So, I mean, maybe a little tweak in the wording.
Okay. So the other thing is that there is a need to advertise this ERLD value, so this capability of a router to look at an MPLS label and doing the hashing based on the entropy label. So as a consequence, if a router advertises the ERLD value, we conclude that it is entropy label capable. So this means that we don't need the ELC a part of this ERLD value, it's combined. So when we are advertising the ERLD value, it means that the router is entropy label capable. So which may have an impact on how we are defining the protocol extensions after to advertise this ERLD value. We had also some discussion on the binding seed. Because bindings, when we are using a binding seed, there is a kind of action of stitching between two LSPs. We can stitch an SR LSP with another SR LSP by, for example, expanding the stack. We can stitch an SR LSP with an LDP LSP, maybe with an RSP LSP. And as we are doing stitching, we need to be able to know if the tail end, the real tail end of the LSP is entropy label capable, if we want to push an ELI EL on top of a binding seed. So there may be a need to advertise a kind of ELC associated to a binding seed because it's not the end of a particular tunnel.
Stefan, short comment.
Sure.
So, unfortunately, binding seed disappeared from SPF draft by mistake. Actually, it was supposed to be the recipe related stuff, but it disappeared completely while it's still in the SIS draft.
It's still there for LDP.
But not for this use case where you can bind a tunnel.
You can use it to bind an LDP LSP. So you may be able to propagate the ELC from LDP to SR.
Let's not argue about semantics. The point being, we'll need to reintroduce it in separate draft, given that the SPF draft is past everything.
The main point is that at least what we need to do is to say that we cannot put an ELIL on top of a binding seed if we are not sure that the tail end is entropy label capable. Greg?
Okay, thank you. Greg Merskiziti. So I understand that you envision that it could be in a stack that you read, there will be multiple ELI, AL couplings.
There may be.
Yes, and the text says that basically then how you handle this situation is your local implementation or local policies. My question is that, do you think that it might be useful to have it more strict policy saying that the first ELI, AL that you read should be used? It's an open question.
I think from an implementation perspective, it does not change compared to the existing RSC on the entropy label. So if the existing entropy label processing is just to look at the first one, it works. We are not changing the data plane here.
But
Actually,
So, wait a minute. We are getting close to the end of your time. We are actually going to issue a working group last call within, well, 1 or 2 weeks.
Okay, yes,
So
I understand.
you should probably take the comments to the working group last call.
Yeah.
Agree.
And regarding the strategy of insertion of the entropy label, so we are considering multiple possibilities. So based on the comments that we received, for example,
Sorry, if it wasn't clear, I cut the line. Create this in line, no one more.
I think we should say that all the ELs that are inserted should be the same. Otherwise, there's potential, because if you hash on different ones, you don't want to go in different directions. But I'll take it to the list.
But is there really a need to make it mandatory for the EL to be the same? I don't think so.
I tend to be.
It's simpler, but yeah.
No, but it's probably not necessary. If I always, as a router in the path, if I always pick the same one, but it's scary for me that if I pick it different, if I decide to go deeper, that the flow might be hashed differently.
So the conclusion, so we addressed the comments that we received. So we hope that we solved the main concerns that were raised. And it's time for us to have implementation of this. So we want to close the work as soon as possible, especially because also it blocks the IGP and possibly BGP-LS advertisement of this ERLD. So yes, we need a new working group last call to ensure that we have a consensus.
Start the process immediately. Thanks.
Thank you.
Stuart?
Right, stand in the magic box. And so I've split this. Split this up into a number of phases. This discussion. So first of all, we're going to discuss the objectives of this technology and this approach. So our objectives were to tunnel MPLS segment routing over an IP network in order to connect two MPLS-SR networks together, for example, a pair of data centers. Our other goal, primary goal, was to enable SR to be introduced into legacy networks by tactically introducing SR-capable nodes and at strategic points. And one of the consequences of the way we have chosen is that although it wasn't a specific objective, the system is IP neutral. That is to say, we can support IPv4, IPv6. We don't care. It just works. So look at the two use cases. The top one, which we've seen before, is basically an SR in UDP tunnel joining two SR domains. The other one at the bottom is showing the interconnection of SR-capable nodes, but that we're using to tactically introduce SR into this network. So a technical summary of how it works, to remind anyone that hasn't seen it. So it's RFC 7510, which is MPLS over UDP. We think that we should focus on just this one encapsulation. What this does is to encapsulate a normal MPLS SID stack in UDP in IP. And we address use the IP address to send the packet to the next SR-capable node along the chain. The UDP destination port indicates MPLS below, so this is IP carrying UDP. UDP says MPLS next, and then we go through the SID stack and into the payload. The IGP and control planes are just like MPLS-SR. Source processing is just like MPLS-R, but encapsulated in UDP and IP to the first router identified by the first SID in the stack. To legacy transit nodes, it's just IP. So they simply forward it, don't care whether they're v4 or v6, they can just cope with it. Also goes through firewalls nicely and anything else that might be in the way. An SR-capable node will process the SID stack as normal and then re-encapsulate in UDP and IP to send to the router identified as the next one in the chain. Whether you do some optimization like just moving bytes, or whether you really do a re-encapsulation, that's up to the hardware designers to decide. Final hop strips out the header and just forwards the payload as if out of a tunnel. So a little more detail. The IP header has got the source and destination address, and the next protocol will always be UDP. UDP header has got a source port which provides entropy, so this fully supports entropy within the IP domain. Destination port is MPLS in UDP. The SID stack, as I've said, is exactly like the SID stack would have been in MPLS, and the payload is the unchanged IP header data, whatever you wanted to carry in your IP. Could be a pseudo wire, could be anything. SID advertisements. Advertisements are just like for MPLS segment routing. The IGP or BGP advertises the address of the nodal link and the associated SID. All SID types are supported. We need to add advertisements in routing to specify the encapsulation type and the penultimate hop pop behavior. So those are two things that we need to add. Source processing. We build and impose the MPLS SR stack. We encapsulate in UDP. We encapsulate in IP and do a fib lookup. And guess what? That looks exactly like RFC 7510. Non-transit, transit non-SR processing. It's important that we have to be able to transit ordinary IP nodes, and we can just do that. It just looks like an ordinary plain packet. There is not even a hint in this packet that it is special. So it just behaves exactly as normal. It doesn't need to worry about options or anything. So it's just an IP packet. Entropy works exactly like entropy does in an IP network, the 5-tuple or whatever that you would normally have, and the TTL decrements as normal. So this is absolutely standard. What about a transit SR node, a processing node? If the packet's addressed to me, I do this lot. Otherwise, I just forward the packet. I find the UDP inside and I say, this is MPLS in UDP, I better take a look. I look at the top label in the MPLS SR stack, extract the SID and look up next hop IP address and pop that stack entry and re-encapsulate the packet. It says here, the draft explains this processing in some detail because people had been saying that we weren't being quite clear enough as to exactly what has to happen. So what were the key changes from...
Back here?
Yeah.
It's probably not best to call this SR capable because it's a little more than that. So long as you define it.
Yeah, we're not precious on the names. If you want to call it something else, please send your suggestion. Key changes from 0.0. So we've clarified the forwarding information. We've clarified what happens in transit nodes. We've clarified the entropy handling. We clarified the PHP processing in some detail. PHP processing turned out to have some subtleties, and we're thankful for Jeff for helping us out with that. We've clarified the egress processing, and we've clarified processing of erroneously received messages. Control plane, a summary of the existing control planes and the extensions required to support PHP have been added. So moving forward. One of the things that people have talked about is additional encapsulation types. This draft describes how to do it for UDP. If there is a need, for other encapsulation types, then I think the right approach is to write up a series of data plane specific encapsulation documents that explains how they work in those particular cases, because there will always be subtleties. So we think that they should go out in separate RFCs if and only if there is an established need for that particular one. Control plane, we think the control plane should also be written up independently. And the reason for that is that having proposed that we split the data planes, we would like to have, as far as possible, a single control plane document that essentially is extensible. So it will just say what the encapsulation type is, and there'll probably be another document that explains any of the nuances of that, but essentially to have a core control plane document that is capable of extension to multiple encapsulations. That way we are future-proof, but without initially cluttering the document up with types that we don't know whether we need or not. So it is a simple solution to a simple problem. It will be useful to have the problem discussed in the spring working group, and we are presenting it in spring later this week. We would particularly like experts to flag up their concerns and missing functions. In our view, the solution belongs in the MPLS working group.
Hi, I'm Himanshu from Siena. So I have a working group related question. We have overlapping drafts. You have this one. I think there is a follow-on one which is identical to this one. So we need to decide as a working group whether we are going to process both of them, or we are going to combine, or what's the deal here?
We're talking to the two sets of authors are talking.
Talking to, okay, so you plan to combine the effort and...
We're talking.
Okay.
I think we'd like to go on to the next question, please. No, I mean, if you had another question, that's great, but...
No,
Wim Hendricks, Nokia. I had a question related to, which I asked on the mailing list, but we said that we would support it, but basically the question is the following. Do we envision that this technology supports interworking between segment routing with MPLS native transport?
Sorry, I didn't quite hear your question. Sorry.
So the question is, so this is, I call this segment routing over UDP, right?
Yes.
Would it interop with segment routing over MPLS?
Yeah, that's what the way I would see it working.
If that is true, we have to specify the entropy behavior on how you map the entropy from the UDP source port into the entropy label on the MPLS side, which was presented by Stefan. And there will be some complications with that, probably.
Yes, sorry? It does do that. My co-author says that there's already text on that.
I read the latest one, and I don't think.
Okay.
Well, so if it's not clear,
slope offline, please.
Okay, yeah.
we will address that. We will
yes,
note that.
My main question
is
is the draft assumes that there is interworking possible with segment routing over native.
Yeah, our assumption is that interworking is possible. If there's any bits missing, please tell us, and we will fix it.
I don't know how does the country play how to work, because if the two SR domain are different IGP area, so how does it knows which destination IP we can encrypt for the first hop label?
Sorry. So this is how do two disjoint know?
Two SR domain.
Yes.
Is different IGP area.
Yes.
So how does he knows the label? The label we can encrypt which destination IP. Yeah.
Oh, right. How do you know the labels in the two different domains?
Because we changed the label to UDP head, so it must know which IP, which destination IP it can encrypt.
Well, I
think it's about how do you know which is the next SR capable node?
I mean, if it is two IGP area, SR domain is two IGP area, so he didn't know which destination IP it can encrypt.
So
yeah.
Adrian, you can sit down if you're going to.
I think he was going to answer the question, actually.
Okay, try it, but be quick. We are running way over time.
Come and stand here, you're an author.
Then I think the answer, if Kariti's restatement of your question is right, is that you do not target the next SR-capable node. You target the next node identified in the SR stack. So the UDP tunnel goes between things that are in the SR stack, not between SR-capable nodes.
Okay.
Okay, and take the list now. Next is Yahoo.
If we have to add stuff, we will. You can carry.
Hello, everyone. I'm Xiaohu from Huawei. Let's talk about unified source routing instructions using MPS label stack. Major changes since there are 3 versions include the number of calls on the front page has been reduced to meet the calls number limit requirement. Some tests have been ended to clarify how to while reperforming hash on the MPS SAM routing packet when re-encapsulate that MPS SAM routing packet with IP-based tunnel handler, such as UDP tunnel handler. More specifically, when the encapsulator couldn't obtain at least one chip label from the label stack that received the MPS SR packet, it's strongly recommended that the chip information carried in the original received MPS over UDP packet should be stored. When stripping the label stack, when stripping the UDP tunnel handlers, in this way, the triple handler could be reused. That means it can be directly copied to the new UDP tunnel handler. In this way, it can overcome the load balancing issue associated with the current MPS SAM routing scheme due to the readable label stack dips and maximum label insertion capability hardware limitations. As you can see from this figure, no matter the underlay is MPS, IPv4, or IPv6, the source routing instruction is uniformly encoded as an MPS label stack. In this way, this technology combines the best of the 2 technologies. That is simplicity of IP as an underlay and the flexible programming capability of the MPS as an overlay. That means in this approach, the traffic engineering or source routing capability is realized as an overlay capability. As you can see from this figure, the unified source routing can be seamlessly integrated with the current MPS VPN technologies by using consistent network programming instructions. That is MPS label stack. Since the unified source routing leverages the existing powerful MPS and routing technology, it can interwork with existing MPS and routing technology seamlessly. And it's very beneficial for the incremental deployment of MPS and routing technology. For instance, in the EPE case, the fabric between the egress and the ingress could be IP fabric. There's no need to upgrade it to be MPS fabric. In fact, Google's Expresso is concrete example of this usage. First, unified sort routing leverages existing hardware capabilities, such as MPS SR forwarding capability and then MPS UDP tunneling technology. Second, it facilitates the incremental deployment of MPS SR. Third, it overcomes the load balancing shortages associated with the current MPS SR. Fourth, it can seamlessly be integrated with existing MPS VPN technology. Last, it works across both IPv4 and IPv6 underlays. Implementation status. Currently, Nokia has implemented it. Cisco has developed a demo for this. Juniper and Huawei has decided to implement it. That's all. Any comments or suggestions?
This is Ahmed Bashandi, Cisco Systems. I can see that this draft, I'm a co-author in this draft, and the previous one that was presented, they are not really offering any new MPLS standard. They're not offering new behavior in the MPLS forwarding plane nor the control plane. Is there a particular reason why they are sitting in this working group? I think Spring is a much more appropriate work there. For here, there is really, I mean, MPLS over UDP is an RFC, MPLS over GRE is an RFC, MPLS over L2TP is an RFC. Why is it sitting here?
Adrian Farrell, I can answer for the previous draft, which is 7510 was done here, and this is basically a statement of how to use 7510. And it doesn't change segment routing, and it doesn't change MPLS. It's a really simple use case.
If it's a use case for MPLS or Spring, should it be informational, for example, or why is it a standard track?
Yeah, who cares? That sort of decision can be made 100 years in the future when it becomes an RFC, if.
So Wim brought a right point about mapping between entropy field and UDP header and entropy label. So entropy labels could be good when they increase entropy. They could be extremely bad when they cause different treatment within the same flow. So I mean, there are no difference in the way drafts describe this, right? What we need to define here in this working group is how properly map, because every time we hit a SAR-capable node that's addressed, it will have to do mapping. Mapping has to be done in a consistent way. It will use additional hardware resources, so good thinking is needed to address this, and it's different than 7510.
If we're talking only about mapping the entropy to the UDP port, this has nothing to do with segment routing. This is MPLS over UDP, right? But this is called here segment routing. If you want to do something related to MPLS into IP, feel free to do that, but not use the term source routing because it has nothing to do with it. I can do this for VPN labels. I can do this for whatever label, but it's MPLS only. Segment routing should go to Spring.
So, Ali, I'm cutting the line after you.
Okay. Can you explain the difference between this draft and the previous draft?
As co-chair Loa had mentioned in his previous email, the two technologies are exactly describing the same technology. But in my point is they are describing the same technology from different styles. Maybe Stewart draft is more suitable for those guys who dislike MPS or not much familiar with MPS. So we need to disclose some details about how to use MPS over UDP.
So please respect, I actually cut the line after Ali, so please sit down.
Zafar?
I did cut the line if you didn't get it.
Good.
We are over time. Go to the list, that's where it belongs.
Okay.
Go to the mailing list, and that's where it belongs. Yeah, that's what I'm going to say. There is a further presentation on these two drafts in spring tomorrow. Maybe we can take more discussion there. But if I remember, the spring agenda is pretty full. Oops.
Yes, Martin speaking. They are on spring agenda, and we have 10 minutes dedicated to the discussion on the two drafts. 5 minutes presentation and 10 minutes discussion. So
Okay.
if you want to discuss
Great.
more, you can.
So next is who? Oh, it's Greg. Greg, it's your turn.
I'll manage.
You are a little bit short.
I'll try to recover. Okay, it's probably reverse order as I thought, but never mind. Okay, so recently there was a discussion on mailing list about bootstrapping, clarifying the procedure of bootstrapping BFD session over MPLS LSP using LSP ping. And the question was that what is the behavior of their far end and agreement, and I believe that there is proposed text that everybody agreed, is that the behavior is determined by to follow RFC 8029, which is a new version of LSP ping. That means that the sender of LSP ping that bootstraps MPLS BFD sets return mode to its liking. But RFC 5884 states that BFD control packet has to be sent before any reply will be sent to the LSP ping, which kind of odd, but at least understandable that that purpose of this LSP ping that bootstraps the BFD session is not to verify liveliness of LSP, but to bootstrap BFD. And actually, that's why my interpretation, there is a reason to send a control packet first before the reply. At the same time, so there is ambiguity in 5884 what to do, what the far end does with their BFD discriminator TOV if it commanded to send reply. Should it include it? And then how that reply may be interpreted by the sender. Because just a single locally allocated discriminator by the far end is not sufficient to identify the BFD session, because the sender of echo request requires its own discriminator to do demultiplexing. So here is the proposal that sender of ingress LER should set reply mode to no reply, and responder should not include BFD discriminator TOV in MPLS echo reply when replying to echo request with a BFD discriminator TOV. I had a comment and suggestion on a list from Carlos that he suggested that it might be more elegant to say that ingress LER must ignore BFD discriminator if present in MPLS LSP echo reply. That's nice too. So because we had this discussion and it was kind of extensive discussion, I believe that it will be good to agree on some behavior how to reflect this behavior, whether it's errata, whether it's a 5884 bis, or draft, or none of the above, open to the working group discussion suggestions. And probably we can do it. Here is Kireti, that his opinion, definitely.
So, Kiriti Kampela, the first thing is, I'm not sure what we're trying to save by saying that there is the LSP ping should be sent with a do not reply. You can send it with a do not reply, but typically today it's sent with a reply. The problem is when you send it with a reply and you don't get a reply, then you think the LSP is down. From the ping point of view, the BFD is something else. So if you go back to your previous slide, I'm not sure why that's in. I think.
Okay, if I may respond.
Sure.
Again, the purpose of bootstrapping, of sending this echo request with the BFD discriminator is bootstrap the BFD session. Okay, so that's why I think that logically to say, I want this BFD session and I really don't care about the reply if the BFD session is up. If BFD session fails to go up, you will send the reply with error code.
Well, all I'm saying is it doesn't matter which way you do this, so long as you're consistent. If the sender says, I want a reply, send a reply. The BFD session comes afterwards. I do agree that for the second part, either don't send the discriminator or ignore it when you receive it on the ingress. But the first one I think is not necessary.
Again, that's why I use should, because it's like a clue that there is no good reason to send it with a request of reply. But if you want to, you can. So you're still compliant. That's why I should.
I mean, ping is an independent way of knowing whether the LSP is working. BFD is a different way of knowing it, which can operate at a higher speed. So I think it's just, for the cost of one packet, make sure the ping is finished, and then you can start your BFD session. I mean, but that's just me.
Again, this is just a proposal.
Okay. And then if you go back one more slide, I agree that it doesn't matter in which order you send the BFD message and the reply if you're sending a reply to the ping. They should be independent.
Okay, but I need to point the current text is quite explicit about it, and that's one of the reasons why I put no reply, because that makes implementation easier. Sorry, I have this scar.
Greg,
Wait.
You can stay on this discussion if you want.
Yeah, I know. Okay. Yes, thank you.
If you go on the discussion, then
I know. I eating my own time. Yes.
What I'm saying is that we are running over
Sure.
time.
Okay. Yeah.
And I actually managed to calculate the agenda time a little bit.
Okay. Okay. Let's take a next. I will try to be. Okay. BFD in demand more over. So this is an update. The first presentation was in Prague, and the idea is that in point-to-point we can start as async mode and then switch to demand mode. So that's the basic idea of how to use demand mode for MPLS LSP over point-to-point. So that's a history. The scenario is that because the return path might not be co-routed with the forward path, that exactly with the LSP that we are monitoring. The proposal is to, once the session comes up, their ingress LER can set their demand flag, which forces the node B in this diagram to cease sending BFD control packets. But what we suggest is that once B node determines that there is a failure in BFD, then it sends BFD control packet over IP network, indicating that so it's lost in diag mode that we sometimes refer as RDI indication. And that's the red one, it's update, so to clarify how it encapsulates the packets. And node A will respond over IP because, again, receive notification of the failure. There is no reason to send the packet over MPLS LSP because remote node indicates that this failed, likely failed. So node A will send BFD control packet with the F bit set, which will indicate to B to cease to send this failure notification packets. Otherwise, the B continues to send them once a second. And node A, at the same time, marks this BFD session as down, goes to lazy mode, and then switches to async mode. So switches to async mode, sends packets once a second. If this path is restored, then B again will respond to async mode. Session will come up, and A again can put the session in demand mode. So here we go again. So that's how it's envisioned. We welcome comments, suggestions, questions, and yes, I think that we clarified where adoptions might happen. Okay, next please. Okay, that's as well update to their work that been first presented in Prague. In spring, so happened that we have only so far LSP ping defined for MPLS data plane, and this work tries to complement and expand on Spring OEM toolset and discuss and describe applicability of point-to-point BFD over segment route with MPLS data plane. There are two options for encapsulation. So it could be encapsulated as with IP UDP header, as described in 5884 using the Martian destination IP address for V4 and V6, or it could use GEO label and ACH encapsulation. The problem with the ACH encapsulation is that then we don't have a source information, and the source information is helpful. That's why we are proposing, if one to use ACH encapsulation, that you will need to use this source TLV. Again, BFD reverse path, like in 5884, it could be decided by their local policy, whether to follow IP network or some available segment route in reverse direction. But at the same time, there might be scenarios where controlling reverse path is useful, and we propose to use with a bootstrapping with a BFD discriminator TLV, control BFD reverse path that can specify you either fax as a segment route, or can specify segment route as a set of labels. For example, in central control environment, it might be a useful way to define the segment route, just a set of ordered set of labels. We had a discussion, and something that we intend to update this document to point that this new TLV will be a new entry in IANA registry, so it would not be in effect sub-TLV registry. And again, we are looking for comments, questions, and working group adoption. how we're on time.
Well, one question.
Yeah. So because these LSPs are unidirectional.
I'm sorry.
Because of the unidirectional LSPs.
Sorry, if I say one question, I mean one question. So the line is cut after the current speaker.
Okay, so I see no mention for seamless BFD, where you don't need this bootstrapping and everything, and it's simple and it's fast.
Okay, so you're asking why not seamless BFD?
Yes.
For many reasons, and we can better discuss it on the list, but I would say that seamless BFD less controllable. So you cannot say where the return path of seamless BFD is. Okay,
Yeah,
but we can discuss it in more details in the list.
Okay, thank you. Adrian, you're next. No more questions on this. You have to take it to the list. Just now, if I space out evenly, it's 9 minutes to speak.
Right. Okay, I'll try to do this quite quickly because it's already been presented in the SFC working group. So this is another of those documents where it has there's slight debate about where it should live. So slide about where should we talk about it, that's all the chair's problem. For those of you who don't know SFC, a quick architectural overview that packets are classified given a service function chain that needs to be executed, and that's expressed by forwarding through service function forwarders, SFFs, that deliver to local service functions, get the packet back, and then forward it onwards. There may be a thing called a proxy between an SFF and a service function, and the point of that proxy is to allow you to use legacy service functions without being exposed to the SFC mechanisms. So what we're trying to do is not obsolete or replace the work that the SFC working group has done, but to enable that work in... Sorry guys, I'm finding it really hard to concentrate on talking while you're talking. Oi! Sorry, I don't mind you having a conversation, but if you want to do it while I'm presenting, please do it outside because I can't think and hear you at the same time. So yeah, we're trying to enable the service function, chaining function in existing MPLS hardware. So essentially we can make an MPLS router that exists today into one of these SFFs. And we want to do that in a way that supports label swapping and label stacking as well as mechanisms. And we want to achieve everything that the SFC architecture allows, including metadata. So what we're doing is using a basic two-label unit that's a context label and a service function label. And we push those onto the stack, and we use them slightly differently for swapping and segment routing. So in the swapping case, this maps nicely to the fields in the NSH that the SFC working group defined. One of them is identifying the service path that we're on, and the other is showing where we are in that path to deliver to the service function. And we get the TTL as well for free there. And that looks sort of fairly logically like the NSH. There's a little bit of constraint that we're playing with only 20 bits, where the NSH has got more bits to use, but that's just constrained on the number of paths that can be supported in the network. The stacking approach takes multiple instances of this two-label unit, and you can use that as the context label delivering to the SFF, so it's a SID, and then the service function label underneath delivering to the service function that's local, and then you strip those two off and off you go along the path. Metadata is the big question and possibly the main reason to do this work in the MPLS working group. Putting metadata inside an MPLS packet between the label stack and the user data is something that gives me the heebie-jeebies. So we've defined a way of doing that with indirection, where you push in a special purpose label and a label that says this is an index to the metadata, and that table, that index, what it maps to can be populated by a number of different mechanisms, in-band, out-of-band, management plane, etc. But we define a way of doing it in-band, which is to send a packet which has all the labels on the top that will cause the packet to follow the service function path. But instead of having user data, there's a special purpose label that says what follows is metadata. And then we pick up metadata encoded as an LTV, just the way the service function training working group have defined it. So this data would follow the path and would be picked up by people that care about it and otherwise would pass through. So we've been working on this a little while and polishing it. The author think it's relatively stable. It took us quite a bit of effort to come up with a solution that looked as close as possible for the label swapping and the label stacking approaches. And we wanted to make it work with the best control plane document that's out there. We think from there onwards it's pretty obvious, and it's in the MPLS Charter in particular because it asks for new special purpose labels, but we leave it up to the chairs, etc., to decide where to put it. And then questions.
Okay. You propose two MPLS-based service chain approaches. In the former, it seems that you just propose another containers to contain SPI and SI values. Is my understanding correct?
There's a two label stack entries contain those values, yes.
Not reuse existing MPLS forwarding behaviors, right? It has no difference from the SH-based forwarding behaviors.
It's no different from the forwarding behavior, except that it will work in existing hardware.
No. It's just a different data format, but the current MPLS forwarding behavior has been greatly changed.
The current MPLS forwarding behavior is, well, I can't speak for your hardware.
Yeah. In addition, it's also a stateful service chain approach. It's much similar to the SH-based approach. Do you think we need two stateful service chain approaches in IETF?
Do we need stateful service chain? Yes, the service function training working group has defined stateful service function training. So yes, I do think that the RFC that is shortly to be published is right.
Yeah, but in your job, you propose another container for SPI and SI values. My question is, do you think it's value to reinvent the MPLS label stack format-based service chain approach for IETF?
Adrian, see how this start to look like discussion is very suitable for the mailing list.
Okay.
Please take it to the mailing list and do that.
Okay,
we have 3 people in the queue now, and see how you're done.
The next question.
No.
What's the major difference between
Corey, we
the
can't
second
spend this
job?
time. We have 3 people in the queue. You have 1 minute each.
Okay.
See how go sit down.
Okay.
Yeah, so Adrian, I had the same comment in SFC that the reason you're saying that it should be here because you're defining a solution and that's need to be worked here. But I think before you define a solution, it needs to be dealt with an NFC group where there is expertise in terms of is this the right approach? Because there are other proposals in this area, and doing this work in MPLS working group as a starting point would be wrong thing to do, because this is not the place. If there's a need, we can come back here.
If you're saying I should present this in the service function training working group, I agree with you, and that's why I did earlier.
Okay.
Stefan from Orange. I agree that this is an obvious solution. It's straightforward. You just told that you are targeting the existing hardware, but I'm clearly worried about the label stack size and the ability to push as many labels as we need, especially because today we already have some issues with SRT.
Yeah, I tend to agree that certainly a significantly long service function path might have some challenges with the label stacking approach. Although it's kind of neat that you can indicate the SFF in the label stack. But yeah, I mean, it's a kind of trade-off between Stuart and me about which we like, and I particularly like the swapping approach.
Yeah, I fully agree. The main point is that we still have this boundary of how many labels that we can push. So as a vendor, do you think that with the next generation of hardware, we can put, I don't know, 30 labels to ensure that we can cover every use cases?
Tens of thousands, 2 to the 20.
If you can do SRv6, you will be able to do this.
Yeah, no, I agree. There are limits.
Thank you.
One thing, Wim Hendricks from Nokia. I had one clarification. When we do metadata in the stacked case, do you envision to copy that metadata in multiple parts of the stack if the service function needs to consume that all the time, or how would that be done?
Yeah, so this is in the stacking approach, obviously, not the swapping case.
Yeah.
Originally, we wrote it up like that, saying, well, you can put metadata multiple times in multiple places, because you might be targeting some metadata at one service function on the path and some metadata somewhere else. And then we looked at what the NSH does, and the NSH is, the metadata goes all the way through, and thought, well, let's start with just putting it in once.
Because then we need to have a behavior on how we interact with service functions if they do not, let's say, support that metadata and stuff like that, right? So you need to define that whole proxy behavior.
You're absolutely right, but that is an SFC working group problem, because that problem exists in NSH.
Yeah, okay, but if we define here the behavior on MPLS transport?
No, so if you get metadata delivered to you as a service function and you don't know what to do with that metadata, that the behavior for that is for the SFC working group.
Yes, but there will be an implication of that behavior based on the MPLS, let's say, label stack, which you are imposing to that function.
So my feeling about this is that this is an excellent discussion for a mailing list, both here and in SFC. We have Jim coming up, chair of the SFC working group. If you want to comment now or comment after the next presentation, you can do whichever you want.
No, I was actually just stretching my legs, but so no comment.
Okay.
Hi, my name is Shao Wen from Juniper Networks. Actually, we propose another method to leverage MPLS segment routing together with NSH for the service training function somehow. So on behalf of all the co-authors, we kind of propose this method previously, Xiaohu mentioned. So the unified source-based routing, somehow the name here, which can overcome the boundary between the IP and MPLS, and which is perfectly to define the path for the service chaining, maybe in between the multiple data center and so on. So whether this is a MPLS-based data center, segment routing-based data center, or IP-based data center, all the services can be passing through here. So then the next part is here. if you look at the service function here, so a majority of application right now, they don't understand segment routing or MPLS capability yet. And a lot of capability boxes not even can manage the network service header function yet. So we actually propose a method for SF forwarder to assign a label for service function here. We know we are in discuss with other people to try to assign the label for the service pass, the whole pass for another label somehow. So it's still in discuss right now. So, but the idea here is kind of you blend it into the service function and the services forwarder, whichever in the different packet order, the sequence here, the label design which node you go to next. Then some special function like here we have as a service function, which is we need to remove all the label stack and maybe pop up the network service header for that, which we can discuss in later here. But you can see the proposal here actually proposed the controller or service provider or anybody can define the path from the very beginning. Either way, this one is a label or the IP here. So even in the middle here, you have a no segment routing, no IP capability box here. You still can assign the label for that one for next one. So here's the label for forwarder 2 here, maybe the OVS software capability here. When this one handled all the process here, then they come back with this label, they will mapping to the UDP tunnel or the UDP interface, then send directly to the OVS to process as well. Then you also have the service classify, and you have an end-to-end solution here. So we believe segment routing or MPLS label could be a very good way to define the path. We never intend to include the metadata directly into MPLS label stack, causing some hardware problem and so on. So, but there's indicator. Xiaohu mentioned for the MPLS packet forwarding. Then if you try to include another header, such as NSH here, you can indicate the next header will be NSH here. Yeah, I mean that can be part of this transportation path, can be part of even the TCP session, the metadata somehow. But we use NSH as a container to contain the metadata only. Then all those kind of path-related information will go to the MPLS label or the UDP tunnel here. So the idea here is for those service function, if they can understand the segment routing, understand the network service header, that's good. So we can set up the neighbor directly to them. Maybe they can understand. Then if the guy doesn't have any clue, then in that case, I may need to remove all the labels here. And if they can understand the network service header, then I will pass all the network service header information, SPI, SI information to the processing, then come back. Then based on those one, we can put all the label back here. So sometimes there's a mapping between the requirement for the mapping between the network service header and the segment routing label stack here. But that's put more stateful information on the SFF here. But if you really want to keep this SF forwarder very simple, you may have an auto function.
Just now we have 2 minutes.
Okay.
If you want to allow discussion,
Okay.
then we have to wrap up pretty quickly.
Understood. Yeah. So basically, here is the proposal. The advantage for this proposal is kind of we know that a lot of people working on the VSLAN plus NSH solution. So here we actually propose because that VSLAN and NSH only can define one segment here. They don't have a path information. So our proposal, we have a path information. which can provide end-to-end solution. Then we have a less status on the forwarder here. Then regarding the performance here, we do not need any special treatment here. The performance will be MPLS performance, very good here. So build both for IP and MPLS here. So that's all from my session.
So Jim.
So Jim Guichard. So I actually have a lot of comments, but I'll try and keep them small. So I understand why Adrian's doing what Adrian's doing, because you know, and he's not hiding the fact that MPLS really can't mimic everything that NSH can do, and you're very clear about that in the document, and you're trying to get a mechanism to do a kind of NSH thing using the existing hardware. So that I can appreciate. What I'm struggling to appreciate is why we want to build service chaining capability into segment routing when it's already been done. Bearing in mind that NSH could quite easily do the segment routing function if we wanted it to. We just haven't pushed that. And if you think about it, a traffic engineered path using NSH is simply a service chain built of SFFs. So you could do that quite easily with NSH. Now, the biggest problem is the services. And you need to talk to the service vendors, because they're not typically, at least from what we've seen, they're not interested in having to build an MPLS stack or a segment routing stack on their devices. They want something simple and easy to implement, which NSH is.
Yeah, understood.
Yeah. Now, if you insist on doing it with segment routing, then my suggestion would be that you actually integrate segment routing with NSH. In other words, what you do is you strip off the segment routing at the SFF and you use the path ID from NSH coming back from the service to tell you which segment routing stack to push back onto the packet.
Yeah, actually, very good suggestion. We're actually thinking about it to SPI to get back all the tunnel stack, label stack here.
Okay, thank you. Actually, line cut off to Sam.
Okay.
I think one question to Jim first. Jim? Okay, so I think that the appropriate thing to do here is that the SSC chairs and MPLS working group chairs actually discuss on how we want to proceed with these drafts. Yeah. Okay, thanks. Less than 1 minute, Sam.
Okay, Sam Aldrin. I'm trying to understand, you're bringing the context of data plane into SFs.
Mm-hmm.
So you're pretty much making every SF to support the data plane. And the question for you there is, what if it doesn't support?
Sorry, sorry, I missed the question. So
what if the SF do not support the network stack?
So the SF of service function, if they don't support any segment routing or NSH, we can remove from the SF forwarder and passing all those information to the service function. Yeah, we can remove it. Then we are thinking about it to get back all the label stack. Later.
So in other words, let me ask you, why do you have to push the data plane into this whole realm? Why can't you do just with
Sam,
control plane?
You have to go to the mailing list from here. We're running way over time.
Thank you for
all the 7 minutes for each presenter left. So Su Fang, you next. Isn't it? Su Feng Lu? It's 8. No, it's not the right one. Huh? No. It's not the right presentation, we know that.
There's a right, this is a presentation supposed to be done by Tarek, but he is not being able to come here, so I just give the brief update on behalf of Tarek. So this is update on the activities for Yang modeling in the MPLS working group. We also provide some information for the dependencies in other working group which are using our models. Okay, here's some working group documents. So we have MPR base, MPRS static RSPs, and MPRS RDP, MPRS MRDP. So these are 4 working group documents. For the MPRS base and static, we're still working in progress because recently there are some changes in the Yang area, so we have been waiting a little bit. So now it's pretty much ready. So we are working on the updating the model to be NMDA compliant, and we are trying to align with some other models affected by the NMDA architecture. So those models include the NetMod IFC 8022, which is IETF routing, and also the interface model 7223. They have posted the NMDA compliant model, so we are ready to update our model also. And also we are trying to align the model with another draft in the RTGWG, the routing types. So after that, we're also trying to get the review from young doctors. So those are the items which we are trying to do for those 2 models. And we have RDP and MRDP. Those 2 models will be reported separately next by Cameron. So this is a duplicated slide here. So we have other working group documents from other working groups which are using our models, including the RSPTE, BFD, and SR. We also have some individual documents. Here we have OEM related, MPLS TP OEM and the RSP pin. And the authors are actively working on those models. And they are committed to finish the work. And they are asking for comments, feedbacks, suggestions, and any active participations. So we also welcome any feedbacks, comments on anything we're missing here, and the team will be happy to finish those. That's it.
Okay, thank you.
Just a quick note that probably I should have mentioned that and helped in the slides, that next for MPLS OEM Yang models would be 6374.
Okay, yeah. Cameron?
Okay, hello everyone. I think we're running late for the time, so this is going to be a very short update anyways. So this is a combined update for LDP and MLDP Yang model activities that we have been doing. So first I'll go through LDP, a very quick one, and then we'll go to MLDP. So since last IETF post IETF 99, we have few things pending for MLDP, for LDP drafts. We got a couple of reviews by young doctors on our revision 1 as well as revision 2 that we have to address. One of the major comment was to align with this NMDA model, a revised data store model, as well as specify some other default values and some other cleanup. So these were the main pending items for our LDP draft, pending that from post IETF 99. So what we have done since then, the team has been meeting since then. We have addressed most of the comments from the Young Doctors review on revision 01, actually all of them, from the Young Doctors review comment on revision 2, we have addressed some of them, but we haven't fully finished addressing all of them. So we plan to do this before the next IETF. And we have updated our model to become NMDA compliant. And we have specified the default values for most of LDP parameters. There's still few pending discussion among the author and the teams. And we have changed the hierarchy a little bit that I'll go through in the next slide. So this, unfortunately, we missed the deadline for 10:30. So we posted draft just on Monday, yesterday. So the tree now in LDP looks like basically LDP discovery was mistakenly under global. So it has now moved back to now like on the same level as the peer and the global hierarchy is, as well as in terms of open config style that we have originally in our model. Then we started way back in IETF 92. Since then, we have actually presented this model update every IETF almost. It was config in state model, so that's gone now. So it's now an NMDA compliant. So we have only rewrite parameters as well as read only without any specific configured state subtrees within our model. So that's an NMDA compliance we have done. For the next step for this model, as I said, we appreciate, first of all, we appreciate Young Doctors review. Excellent comments. We have few comments to address, and we have, if any further comments come, so we have to address those. I think we, as an author, we think that this document is getting very close to working group last call. Once we address all those remaining comments as well as some minor cleanup, we expect this next revision of the document to be ready for a working group last call. So we're not yet calling working group last call on this document, but hopefully by London IETF, we should be able to call a working group last call or request a last call on this document. So that is the status on LDP. Any comment, question before I go to MLDP?
Question, what you actually just said, you want to have the working group last call before the next IETF?
We are not calling yet. I'm saying we are hoping that if once we address all the young doctors review comments, next revision that we'll post, that should be almost ready for working group last call. I think we'll make this call at that point in time. So we're not calling working group last call yet. Any other comment? All right. I still have MLDP. And that's a short one. Yeah, it's the same slide right after that. Okay, so right, so for MLDP, also it's getting close to its final towards its final journey. The main changes which were pending for MLDP as well were alignment with the NMDA data model as well as default values for our configuration parameters. So we have since last IETF also updated our model to become NMDA compliant. Changes are very similar to what I just highlighted in LDP, and we also posted revision 3 for this this particular draft on Monday together with LDP draft. For this draft, we haven't even got any Young Doctors review, and I think we are formally requesting a review by Young Doctors at this point in time.
It should say requested.
Oh, requested. Yeah. You already requested. Thanks a lot. So we have requested a Young Doctors review, and then we hope to get some comments and address them in appropriate time and post a new revision. So for this document, next step is not working for last call, basically to address Young Doctors comments that we get. But next IETF LDP is the one that we are pushing and hoping to get working for last call. That's it for a short update on LDP and MLD draft. Any questions?
Okay, thank you.
Thank you.
So thanks, Cameron and Su Feng. Now we're actually back on time. So I think Adrian next, or Sharada.
Good afternoon. So I'll be presenting the MPLS SR path identifiers. So the problem space is an interface is running hot, and it's an SR network, so multiple SR paths using that particular flow, passing through that particular interface. We need to find out which SR path is taking how much traffic, and based on that, we need to reroute the SR paths. So SR does not have any state in the core, so on a transit node, we really can't figure out which SR path is carrying how much traffic in a very easy way. Counting at the ingress would also not be sufficient because SR is inherently ECMP aware. So what happens is if you measure traffic at the ingress, you really, because there is ECMP hashing in between nodes, so you really don't know on a particular transit link which SR path is contributing for how much traffic. So that's the problem space. And also the source, because in SR, you just pop the labels and then you move on. So you really don't know where the originator of the traffic is. So you only know where the traffic is headed to based on the remaining labels in the label stack. So high-level solution is to insert an SR path identifier in each MPLS SR packet, and then count them based on this identifier. So the SR path identifier has to be globally unique because you're going to count on a transit node. The SR paths which are passing through the transit node should be globally able to identify the SR paths. We should be able to find this globally unique value in the packet header, and then we should be transparent to legacy implementations. Yes, Stuart.
Do you mean globally unique in the true sense? I mean IPv6 globally unique, or do you really mean domain unique?
It's a unique identifier which can uniquely identify the SR paths in the entire network, irrespective of from what the ingress is.
You mean domain unique?
Yes, yes.
Okay, so if you're planning to use this for any function on a transit node, then you will have the same problem as an entropy label.
Yeah, right. We can move into the solution space and see what the solution is.
And another question is, have you looked at draft MPLS source label from 2014?
Yeah, right. Yeah, I do have taken a look at the source label draft couple of years ago, I guess, in MPLS working group, which was somewhat similar, but it was not putting a unique path identifier into the packet. It was putting a source label, I guess. So with just the source label, you will be able to identify who is the source of that. And from that source, there can be multiple SR paths. You wouldn't be able to figure out which SR path exactly.
Yeah, but see, the thing is that even with the second label you have, because in the transit nodes you can have ECMP, you're still losing this physical path identification. So you only know where the source of segment route sent it, but you don't know how the node traversed because these packets can be ECMP in the transit nodes.
Yeah, so the problem space is to, on a particular transit link, the problem space is to figure out how much traffic a particular SR path is carrying. So the problem space is not to figure out what is the exact path of a particular SR path. So you know, the problem space is like you have a link which is running hot and you want to know which all SR paths. So you already know which all SR paths are going over that link and you want to figure out how much traffic each one is carrying. So that's the problem space we're trying to address.
Okay.
I know this is kind of distorted picture. So, so we are inserting a path identifier into the label stack. So we need a way to identify that there is a special identifier in the label stack and it's not really a label which can be used for forwarding. To identify that, we need a special indicator label, and this has to come from MPLS reserved label space. So this is called SR path indicator label. And below that, there is SR path identifier. This is a unique, globally unique value for each SR path. So this is a 19-bit identifier, and there is one leftmost bit, which is the C bit, which indicates whether there is a node identifier below it or not. So altogether, you have two models. This is the first model where there are 3 additional labels getting added. First is the path indicator, second is the path identifier, and third is the node identifier. Node identifier gives you from the originator of the, or ingress node of this particular SR path. So the advantage here is if a path identifier is globally unique, you always know from where it originated. But if it is local to a particular node on which it originated, then you really need a node identifier. So when there is a node identifier, this path identifier is scoped per node, per ingress node. So you get 19 bits of path identifier and 20 bit of node identifier, which together can be used as a unique value to count the SR path, SR traffic for each path. So the second model is uses just 2 labels. The top label is the SR path indicator, and the bottom label is SR path identifier, and the C bit indicates that it's a 2-label model based on whether it's 0 or 1. So in this model, the path identifier is a 19-bit identifier, which has to be globally unique across the entire SR domain. Yes, Jeff.
Yeah, so said you're going to end up competing for label space with entropy labels. However, I think, so how are you going to derive the binding between special label and LSP associated with? There are going to be some out of band that's going to do the correlation, right? You'll have something in name of the counter probably. So
I'm not clear with, can you repeat your question?
You need to resolve value of the special label to the counter associated with particular LSP, right?
Yeah, so the way this works is the forwarding plane will look for the special SPI, which is a MPLS reserved label, special label. So it'll, in the label stack, the forwarding plane is going to look for this particular label, and then it knows that below that is an identifier. So
my point, what you're trying to do is more applicable to generic MPLS where we've got 20-bit label space. In segment routing, any label outside of sRGB is special anyway. And we've got SRLB, which is the local block, which could be for this purposes, and it's just single label per domain. So your space, label space is shorter, and it's already there. So
yeah, I understand what you're suggesting, and I think that could be one of the solutions where you allocate a special global block which is specifically for SR path identifiers, and then you provision it on every node that this is the block which is special, which is specially used for.
it is already
routing.
there. It's called SRLB.
SRLB is local block. It's local for every node.
It doesn't matter. You can use it if you wish. It's locally defined.
Yeah, I think you need 2 blocks.
So Jeff, I don't think SRLB can be used. We can discuss offline because SRLB is local to a node. And what we really need here is a global block. It's going to be a new global
You
block.
could make it global from configuration management perspective. At the point being, you only need 1 label. You don't need special label and then indicator that there's a special label.
No, we still can't use the same because SRLB is already being used for binding SIDs and other purposes. So you really need a special block which says, oh, this is SR path identifier. This is used for counting and not for forwarding. And that doesn't exist today in SR. You need to introduce, I'm saying that's okay. I mean, this is one of the solutions, yes.
Just to think about.
Yeah, this is one of the solutions which gives you only with 1 label. You could achieve what I'm explaining here. You could achieve with just 1 label. But the problem with this 1 label approach is you really need to dedicate a global label block for your SR paths. I mean, there's never a good number. Based on deployments, today you might think that 100,000 labels, and then tomorrow that's not sufficient. Those are the problems that that have to be, but this is a valid solution, but for deployment, there are certain problems with this global block and partitioning the labels. And
so I've always been, the rule that kind of Eric and everyone kind of taught me from day one on MPLS is never ever use a special purpose label if you can use an ordinary label to do it. I believe that there are unlikely to be more than a couple of thousand nodes in your domain. So why not just take a couple of thousand extra labels and use them to indicate source? You can special purpose process it if you want. It's only a couple of compares to find out whether you're in the block or not. Sorry? But they want to identify the source node, not the source LSP.
So talk to the mic, and you need to be pretty quick about it because now we're using Stuart's time for next presentation.
I'm Mark Chen from Huawei. I think actually there's too many options that can be used to identify SR paths. You can use one label solution, you can two labels, 3 or 4 labels. That every solution has its own pros and cons, and we need to discuss which one is better for this.
Yeah, sure.
Please go ahead.
It's just while working with or talking to pretty much every hardware vendor on MSD stuff, the world is not as rosy as you might think. There's huge costs associated with increasing label depth. Maybe there are 2-3 NPUs who can go 10 plus label, but for the rest, we're pretty limited.
Yes, label stack depth is a concern. I do agree.
Okay. Please wrap up.
Yes. So where do we place it in the label stack? It's very similar to entropy label problem. So you need to be able to read that, get that SR path identifier. So the solution we would need is very similar to the entropy label that was presented in earlier in the meeting today. So another option, so another problem is the sub-SR paths. Like you could have binding SIDs used in your label stack, and then how do we account for this? These are sub-SR paths. Like these would get replaced by multiple labels. So what we're proposing here is you really need end-to-end SR paths, identification of those paths, and then accounting for those. And then so even if the SR path identifiers appear multiple times in a label stack, they would all have to be same, and they cannot be different. So forwarding plane procedures. So when a packet arrives, so the forwarding plane will look up for the special label. And then if it finds a special label, it will check for the C bit and then use SR path identifier plus node ID, or it will just use the SR path identifier based on the C bit, and then dynamically create counters if they don't exist for a particular interface, and then account the traffic on per interface basis. So this is just describing what are the differences. We have this binding SID, which is used, gets associated with an SR path in the network, and then it is used to steer traffic into the SR path. And there were questions around whether binding SID and SR path identifiers are the same. So I've tried to list down what are the differences. Like scope is, binding SIDs could be global scope or local scope. SR path identifier also have similar property. The purpose of binding SIDs is different. It's steering traffic into SR path, whereas accounting traffic for SR path identifiers. So when it appears at the top of the stack, the binding SIDs are popped off and replaced with label stacks, whereas the SR path identifiers are just popped off. And binding SIDs have a 20-bit size, and SR path identifiers have 19-bit plus one additional leftmost for indications. So in spite of these differences, it's possible for an operator that he can allocate an SR path identifier and use it also as a binding SID for that particular SR path identifier.
So one more comment about using binding seeds to create subpaths, it has implication to control plane because PCEP is not full mesh protocol. You usually have PCEP session to ingress node. If you want to instantiate binding seeds on PHP node to the node that's lost in your MSD, you would need to dynamically instantiate PCEP session to that node, or we need to extend BGP, or we need to do something. Today's control plane doesn't solve this issue.
So Stuart, just to mention it, you are using your own time for the next presentation now. So we have 5 minutes left of the meeting.
I was only going to say IPFix can do a lot of this already. It can look at any label stack and report the number of counters and count the number of instances of seeing it. So we should really be trying to use technology we've already got.
So you mean IP source and destination based?
NetFlow.
Oh, okay.
Hi, this is Uma. I have two questions. One comment first, actually. The comment is, I agree with the special global label instead of a special purpose label. So for node sets, like the way you do global adjacency sets or global node sets, you can create the global, this kind of calculating sets, like, traffic counter set. That's a good suggestion. And the comment is, go to the slide where the dynamic creation.
Sorry, we need to move on.
Okay, so the question is, like, you said that dynamically the node has to create this counter. So the node may carry thousands of flows. So there'll be hardware issue creation of, apart from security issue. Maybe
I think you can go through the draft. We've tried to address it. I mean, what are the concerns and how it can be handled with respect to dynamic creation of counters.
Okay, so Stuart, you're up now. Have exactly 3 minutes, and that's what I promised you from the start.
Okay, so I raised these subjects in the PALS meeting, and Loa suggested that I give a heads up over here. They arise from a discussion on the PALS Ethernet control word problem. So the first problem that arose was that RFC 6790, which is the ELI draft, is soft on the definition of how it works. It says if a transit LSR recognizes the ELI, it may choose to balance solely on the following label, the entropy label. So the implication is that an LSR that recognizes the EL cannot be assumed to base its ECMP decision solely on the entropy label. Now that impacts two pieces of technology. It impacts the IETF PALS Ethernet work we're doing, where some operators have reported ECMPing packets, and it means that we can't rely on the things like the FAT label and the ELI as alternatives. The other one is synonymous labels, which we're working on here, which also has a problem. And in fact, OAM in general has this problem where changing the stack to put the OAM in may mean that you misroute the packets. You don't get fate sharing because it's not required that the ELI method gets you out of jail. So I propose to write a small draft and bring it to the next IETF, which proposes tightening up the rules in order that we can rely on the entropy label system to work and allow us to some alternative stack designs that we need. Second thing is that it appears that, well, we know that lots of vendors do ECMP based on packet inspection of the IP, of the MPLS payload, the IP payload. But some implementations appear to detect 0x0 after an MPLS label stack and assume that that means it must be a pseudo-wire control word carrying Ethernet, and then they do packet inspection based ECMP. Unfortunately, they don't always get it right, and operators have been complaining about it causing problems and expense trying to figure out what's going on. The problem surfaced in pseudo-wire, but the wider issue arises from this type of ECMP, and any recommendation needs to be documented in this group anyway, as it's a p-router problem. So I propose to bring a draft to the next IETF on the subject. If anyone has any thoughts, I would be more than willing to hear them.
Okay, thank you. And time is up. So this is the end of the meeting. A reflection here is that it's actually more activity on the MPLS mailing list when we have all the people in the same room than it is when the people are working from home. I don't know, or from the office. I don't know why. Okay, thank you everyone, and see you in London this spring. I have a question. We have only one of the blue sheets. Where are the other? One blue sheet. No one leaves the room. Huh? Yeah. Where the position is. I talked to Martin and Bruno before, and they said that either EFD actually agreed to join in one way. If we do that, that's fine. But if they don't, okay. Don't do that.